Today we are starting new chapter, friction. What is friction? We say the force which opposes motion is called friction. The force which opposes motion is called friction. That is, friction acts in a direction opposite to the motion of the body. If the motion of the body is in the direction of right side, then the friction will act exactly in the left side. If the body is moving upward, then friction will be acting downward. If the body is moving downward, then friction will be upward. It will be opposite to the motion of the body. Friction generally we denote by the sign small f, like this. This is the meaning of friction, symbol for friction. Friction depends upon the nature of the surface, and it is found to be directly proportional to the normal reaction. F is proportional to n is normal reaction, where n equal to normal reaction. Normal reaction. What is normal reaction? Normal is perpendicular reaction. That reaction comes from the surface. So I will discuss about normal reaction a little later. So first let us make an equation here first. This sign will change with the equal sign by multiplying this side by a constant. That constant we write in the form of mu. Class 10 is to write mu for refractive index, but here mu is different thing. Write a mu m, where mu is constant, is called coefficient of friction. Coefficient of friction. Coefficient of friction. That is called coefficient of friction. Coefficient, C-O-E, coefficient of friction. That means mu is a ratio of F that divided by n. Mu equal to F by n. Mu will have no unit because friction is also kind of force. Normal reaction and action both are kind of force. These two forces unit cancelling each other. Mu has no unit because it is the ratio of two similar quantities. It is a pure ratio. It has no unit. Okay, what is normal reaction? It is coming from the Newton's third law of motion. It says action is equal to reaction but in opposite direction. Suppose we are having a surface over here like this. This can be surface of ground. Our body is lying over here like this. Surface will give a reaction. The action on the surface is the weight of this body. Weight of the body is acting downward, and the surface is giving reaction on the body in the upward direction, that is perpendicularly upward. This is called N. 90 degree to the surface. The reaction will be exactly 90 degree to the surface. This is called normal reaction. Action, that is the weight of the body acting downward, and the normal reaction will act perpendicular to the surface in the upward direction. It is called normal reaction. Similarly, if the surface is tilted here, so the surface is like this. Here is the surface, and the body is lying like this. The body is lying this way. Here is the body lying. This time the normal reaction will be perpendicular to the surface. This is the surface perpendicular to ground. This is the perpendicular. Here is the perpendicular. Perpendicular to the surface. This is called normal reaction. If we are having a surface like this, there is the normal reaction. This is the surface. You have to draw perpendicular to the surface. Perpendicular to the, it should look like perpendicular to the surface. This is called normal reaction. This is how we draw. That is, more the normal reaction, more the friction force. Less the normal reaction, less the friction force. It depends on that. Friction does not depend on the area of contact. It does not depend on the area of surface of the contact. It depends on the nature of the surface. If the surface is rough, friction will be more. If the surface is polished, smooth, then friction will be less. It does not depend upon the surface area of contact. So friction, how to measure mu into n? Mu is called coefficient of friction. The value of mu depends upon the nature of the surface. If the surface is rough, the value of mu will be more. If the surface is less rough, the value of mu will be less. Normally, no surface is perfectly smooth. There will be always some roughness, some ups and downs, some unevenness will be there always. And that causes friction. That will generate friction. Friction is actually interlocking of the surfaces in contact. Like the surface will get interlocked like this, the motion is opposed. That is the cause of friction. So friction mu value depends upon the nature of the surface. Mu value can be 0.8, 0.6, 0.4, 0.2, like this kind of value. Either it will be given or you may have to calculate that. So F is equal to mu1 is the formula. Friction formula is this much, mu into normal reaction. So that formula you have to remember. Now how to calculate normal reaction in different situations out here. If the surface is, this is the surface, plane surface, that is horizontal surface. So weight of the body will be acting downward here like this mg, and normal reaction is like this. So since the body is still at rest here in equilibrium, that means normal reaction will be equal to mg. In this case, we will be writing like this, n equal to mg. We write like this, n equal to mg. Out here, the weight of the body will act vertically downward here. Weight of the body is mg here, vertically downward. And this is the inclined surface. So let us take inclined surface like this. This is the angle theta here. Then, do you think this n and mg are values in each other? They have to be equal in value but exactly opposite in direction. So they are not. So we have to break into components here. In inclined plane, how do we break into component? Mg will be broken. This will be theta. One component will come here. One component will come here. This will become mg cos theta. This will be mg sin theta. This component horizontal like vertical here, but here is the angle. This is the angle theta. This angle will be theta. This component will come in cos form. This component will come in sin form. So what is the value of normalization in this case? In this case, normalization value will be equal to mg cos theta. So we will write that. M is equal to mg cos theta. In this case, again we will check. Here is the angle theta. So here the weight of the body will be acting vertically downward. Here again will break like this and like this will break. This is the angle theta. This will become mg cos theta. This will become mg sin theta. That means the value of n will be here equal to again mg cos theta. What I mean to say, if the surface is inclined surface like this, making some angle, normal reaction value will be mg cos theta. If the surface is a plane surface, horizontal surface, the value of n will be equal to only mg. So there will be no component. You can't break mg into components. That kind normal reaction value will be equal to mg. You can have some idea, then we will be doing some theory after that. Let us take a body on a rough surface, not a smooth surface like this. We are applying a force of 50 Newton here like this. Mass of the body is given, mass of the body, m of the body is given, say 2 kg. 2 kg. And coefficient of friction between the body and the surface is given. I take the coefficient of friction value 0.1. Mu value 0.1. For example. So, what will happen now? You are applying a force this way, the body is expected to move this way. That means friction will act in this direction. Friction is supposed to act like this, opposite to the motion. Force is pulling it this side, the friction will act in this direction. How to write on the equation of motion? We will calculate the value of friction here. We like that capital F minus F is equal to motion, ma. This force will be pulling it this side, so that has to be bigger than F, then the motion will take place. We will be writing like this. The value of F is 50. Friction formula we have mu, and let us write mu in first. M value is 2, we can write 2a. 50 minus mu value is 0.1. Normal reaction value. Weight of the body will be like this mg, that is 2 into 20. N value we can write here 20. Because normal reaction will be like this. N is equal to mg. N value will be same as the value of mg, that is 20. Here we write 2a. And now we will calculate the result. Get 50 point and 0 will go. Minus 2 is equal to 2a. 50 minus 2 is 48. by 2 is the value of A. Therefore, A value will come 24 meter per second square. That is answer. This is the example 1. First example here, not from the books, in my own example. So we see the acceleration value is 24 meter per second square and the body is moving. In order to move the body, this force must be bigger than the friction. Then only the body will move. If the value of this force is equal to the force of friction, the body will not move. The body will be just about to move, just about to move. It will not move. If the value of this friction force is less than the value of friction which we calculate, then the body will not move at all. Suppose we are having a body with very less force. Do you think the body will move? The body will be pulled. Answer is no. Because this force value is becoming less than the value of friction. Okay. So this is one example I gave. Now another example. In the previous chapter, if you remember, force and acceleration time, the surface was perfectly smooth. I did not consider friction. So I did not mark the direction for friction. I know directly F is equal to ma. Directly we are done. But when the surface is rough and the value of mu is given, that is coefficient of friction is given, we cannot neglect friction. We have to consider friction into account. We will take that into account and then we will be calculating like this. One thing to be noted here. You know, the motion always takes place in the direction of the bigger force. If the two forces are equal, then the motion does not take place. So friction in this case is acting like this. Let us check this way. By chance, the value of A comes 0, that is F and F are equal. Both of them are equal. That is acceleration is 0, that is the body does not move. But using this method only and the value of A we are calculating, it is coming negative. What does it mean? Negative acceleration cannot be there because body cannot move in the direction opposite to the applied force. You are giving a force this way. There are only two possibilities. Either the body will be at rest or body will move in this direction. Only two things will happen. Body cannot move in the opposite direction. So you are giving a force like this. You think the body will ever move in the opposite direction, this side. It cannot move. That means friction can never be bigger than the value of F. Friction can be equal to up to the maximum value. If friction maximum value can be equal to the value of applied force. I mean this side force, whatever. That means whenever A value comes negative here, we like not possible because body cannot move in the opposite direction. We will make it 0 ourselves because A value, by this method A value, minimum value of A is 0, it can never be negative. So we will make it 0 and that time these two forces, how can the value of A be 0 when capital F and small f are equal? That means the friction value will be equal to the applied force. So we are doing one case or as such, then you will see what is happening. Let us take example 2, you will get better idea. Let us take the body of mass. Now I will take the body of mass 40 kg and the value of mu is 0.2. We are giving a force of 50 Newton here. The force of 50 Newton is applied here. Question is asking two things. First part, find acceleration. Find acceleration. And number 2, find force of friction. Find force of friction. And the force of friction. Two things we have to find. So when you pull it this way, the body is expected to move this side, in this direction, in the direction of the force applied. Then this friction is expected to act in this direction F. We will apply the same method here. We will write capital F minus F. Capital F minus F is equal to ma. Capital F is 50. This force we will write mu into m. So here, this is horizontal surface. So we can directly n value equal to mg. If the surface is inclined, we write n value equal to mg cos theta. Just now write here mu mg. Here we write na. Next step I put the value. Mu value is 40. M is mu value is 0.2. This is 40 and the value of G is suppose 10. Mass is given 40 A. Let us calculate. minus 0.0 will go. It's coming 80 is equal to 40A. This is coming minus 30 by 40 is the value of A. What do we see? The value of A is becoming negative here. Do you think is it possible? The answer is no, it is not possible. We'll add here. This is not possible. If it is possible, then the body's acceleration will be in the opposite direction. You are giving a force like this, but acceleration is in the opposite direction. Does it happen ever? Whatever direction you apply the force, the body's acceleration will be in the same direction. So it is just not A value is coming negative, that means it is acting in the opposite direction. That is, body will be moving in the reverse direction. That is never possible. You giving a force like this, either the body will move or the body will not move. That only will happen. The body cannot move in the opposite direction. No, that means make it 0. This is not possible. Therefore, we'll make A value immediately 0. Since A negative is not possible, that is A equal to 0. What does it mean? That is the body, by giving a force of 50 Newton, you will not be able to move the body. The body will be at rest. A equal to 0, you can write here, body will be at rest. Body will be at rest. Now, what is the value of friction? This is the answer. First answer we got A value 0. This is the answer for first part. Now, the second part. What is the value of friction? Whenever A comes 0, we will immediately refer to the first line, first equation over here, the odd here. How can the value of A be 0 when this quantity are equal? When this and these two of them are equal, then only the value of A will come 0. No? You will refer to the first line only, like this first line. When capital F and small f are equal, then this matrix answer will come 0. Divide by anything, the value of A will be 0. That is, friction value will be equal to the value of F. And what is the value of F? 50. Therefore, we will be writing, therefore, F is equal to 50 Newton. That is answer. So, in whichever case, the value of A becomes 0, the value of A comes 0. So, body will not move and will immediately come to the first line, first equation over which you have written here. You have to make these two quantity equal, then only the value of A will come 0. So that means the value of friction will be equal to the value of this, whatever is coming here. So that is answer. Okay, now the next one, example 3. We are having a body here. That is, mass of the body is suppose given 10 kg and mu value I will take 0.2. This time we are dragging the body, that is, we are pulling the body up by a force F is equal to say 100 Newton, which is making an angle of 60 degree with the horizontal line. This force is making an angle of 60 degree with the horizontal. Okay. Now question is again asking you to find two things. Find acceleration and the force of friction. Two things you have to find. Find, like the previous one, find number 1 acceleration and number 2 force of friction. These two things we have to find. So let us do it now one by one. Answer the first part. So this force is not given horizontally to the surface. It is making some angle. This force will break into two components. Will break into two components here. At this origin we will break. First component will be here and another component will be here. Here is the angle, so this will come in cos form. Here we write F cos 60 and here I write F sin 60. Then weight of the body will show. Weight of the body mg is acting downward. The normal action will act perpendicular to the surface like this. Normal action is acting like this. So this F cos 60 will be acting parallel to this one. This will be dragging in this horizontal direction there, like this. The body will be dragged like this. Like a trolley, we are tying with a rope and dragging. So the trolley will be dragged along the horizontal line like this. So So this force F cos 60 is the applied force. Let us take the value 100 cos 60. 100 cos 60 is half. The answer will come 50 Newton. That is, in this direction the force applied is 50 Newton. That is, friction will act in this direction. You are giving a force like this, then the friction will act like this. This will opposite way. So let us write down the equation of the motion. How do we write? This force is the force causing motion on here. Then 50 is expected to be bigger than F if the motion is taking place. Right here, 50 minus F is equal to ma, because there is only one body which is moving. Now we will calculate 50 minus F formula. Let us write formula here, mu n. M value is 10, so I get 10 F. 50 minus mu value at 0.2. How to take the value of n over here? Since the body is in equilibrium in the upward and downward direction, that is, upward force will be equal to the downward force. Upward, there are two forces now. When this force is acting like this, we don't have this component. Now, because of this one acting like this, there are two components. This component is also acting in the upward direction. So we got two forces acting up and one force is acting down. That means this plus this will be equal to this value. We can check it out. We can write it as n plus f sin 60 degree is equal to mg. This can write like this. So n value will be how much, and the value of n will become mg minus this. Let us write down here. Mg minus f sin 60 is equal to 10. This one is a note. We are making a note rather than that. Let us now calculate at 50 minus 0.2. N value is 10 and G value is also 10. So 10 into 10 we will do. F is 100. Sin 60 value is root 3 by 2. 10A. Now we will be using calculator and finding the answer as 0.2. This is coming 100. This is coming 50 root 3. 10A. Now we check what is the answer. What here? We get at 50 minus 0.2. 50, 100 here. 50 root 3 will multiply. 50 root 3 value will come 86.6 nearly. 10A. So we get 50 minus 0.2. 100 minus this will subtract. Answer will come 13.4. 10A. 50 minus multiplying these two pulls 8. This will come 2.68 is equal to 10A. 50 minus 2.68 will subtract. The answer will come 47.32 is equal to 10A. Therefore, A value will come this divided by this 47.32 divided by 10. 4.732 meter per second square. This is the value of A. This time the value of A is coming with a positive sign here. Mind it. When the value of A is coming with a positive sign, that means the body is moving. The body is in actual situation is moving. It is not at it. When the value of A comes either 0 or the value of A comes negative, that means the body does not move, because acceleration cannot be in the opposite direction. So friction force can never be bigger than the applied force there. So that is the idea. So this time A is coming positive, that means the motion is normally taking place. The body is not at rest. That means what is the value of friction? Therefore, second part we do know. Therefore, friction is equal to. Therefore, the value of friction equal to. If the value of A is 0, then only we make these two equal. This value must be equal. Then only the value of A comes 0. But just now the value of A should not come 0. That means these two values are not. Whatever is the value of F, we calculate. You can see the calculation part. F, everywhere I calculated. At last I got this value, 2.68 I am getting after simplification and all. What is the value we are getting? 2.68 here. So this value we can add as directly 2.68. Unit for friction is also Newton. So that is answer. So friction acts in the direction opposite to the motion. Let us check some other cases. Let us take a body, surface, three bodies like this, one, another one like this. and we are giving a force of maybe 100 Newton here like this. This is M1, this is M2, this is M3. M1 value say 2 kg, M2 is 3 kg, M3 is 5 kg, and the value of G is given 10 meter per second square, and the value of mu is given 0.8. So we had done this kind of problem in the chapter force and acceleration, but that time friction was not considered at all. Now mu is given, that means this surface is not a smooth surface, not a polished surface, then we need to consider friction. Now question says, number one, find number one acceleration of the system, acceleration of the system. First part. Second part. Remember, acceleration can never be negative. It can be zero with all the blocks at rest or positive. Positive some values. Second part. Tension in each segment of the string. Tension in the strings A, B, and C. This is the string A, this is the string B, this is the string C given here, like this. Okay. This is the question. Now let us solve. What force? This force is given not making some angle, this force is given directly on horizontal parallel to the surface. 100 Newton. So 100 Newton will be pulling all the three blocks, but friction will be there. There will be three frictions here. Friction of this, friction between this and this, friction between this and this, friction. Three frictions. Let us mark the friction of this one is acting like F1. Friction of this will act like this F2. Friction of this will be acting in this direction F3, opposite to the motion. So I will be getting the equation as 100 minus like this F1 plus F2 plus F3. Three frictions. This minus friction of all the three blocks will be producing motion in all the three blocks. Like this, M1 plus M2 plus M3. So previously, in the previous chapter, we didn't used to consider friction. This part we used to take. We didn't used to take that this value. This was 0. So 100 minus 100 is equal to this. We used to write, but just now we cannot write because there is a friction. Right here, 100 minus friction formula mu into n. So let us write mu common here. Here I write N1 plus N2 plus N3. Three normalizations. M1 plus M2 plus M3, you can put their value 2 plus 3 plus 5 into it. Continuation, 100 minus mu value I put here 0.8. Normalization of this M1G will act here. Normalization of this will act like this M1. M2G will act here like this. Normalization is acting here M2. M3G will act here. Normalization will be acting like this M3, the upper direction. That means here we can add M1G, M2G, N1 value let us write it M1G, M2G, M3G is equal to, this is coming 10. Or here we are getting 100 minus 0.8. M1G value will be coming 2 into this, that is 20 we can add here. This is 30, this is 50 is equal to 10A. So 100 minus, this is coming 100 into this, will come 80 is equal to 10A. So 100 minus 80 the answer will come 20 is equal to 10A, or A value is coming 2 meter per second square. That is the answer for first part. So we got this answer. Now we are doing the second part. Second part now. We got the acceleration. The acceleration is coming just now positive, that means the motion is really taking place. By chance doing this way and the value of A is coming 0. What does it mean? That means the motion is not taking place. All the blocks are at rest. That means the value of A, that time we have to make ourselves 0. Because negative value of A is not acceptable. Now how to find tension in this string? Tension in the string I will mark as T1. If you consider this part, T1 has, because motion is there, so T1 has to be bigger than F1 to produce motion there in this side. We will be writing this T1 minus F1 is equal to M1A, motion of this block only. Right, T1 minus F1. What is the value of F1? Mu into, we will be writing a mu into m1g is equal to m1a, let us write t1 minus mu value 0.8, m1g, that is 2 into the value of g is 10, that means we can write directly 20, here 2a, and a value we already calculated, that is 2, we will put the value of a also. This and this multiplied with 16 is equal to 4, therefore T1 value is coming to 20. This is the answer for this one. Tension in the string A, we got this much. Now we find tension in the string B. This string B, tension is T2, this will put both the blocks. Here we will be getting T2, this is the answer for, this is the tension in the string A. This is the answer. Now T2 value, T2 will is moving both the blocks. We will write T2 minus friction of both the blocks. That is F1 plus F2 within bracket is equal to motion of both the blocks. Let us calculate T2 minus F1 plus F2. F1 value we know mu into n. Mu here we can write directly n1 plus n2. m1 plus n2 is 2. We get 2 plus 3. 2 plus 3 and the value of A is 2. T2 minus mu value 0.8, n1 value is m1g, and this is n2, you can look at this n1 plus n2 value, m1g plus n2 is 20 plus 30. n1 plus n2 value directly 20 plus 30 is equal to 5, 10. You get T2 minus 50 into this will come 40, therefore T2 value is coming 50 Newton. And the tension in C, that is in the string, this is the tension in the string B, and T3 is the tension in this one, T3 will be same as 100, same as the applied force, T3 is equal to 100 Newton directly. This is there in the string C. So this is the solution for this question. If we are considering friction, so the solution will change because friction will be taken into consideration. So today our lesson is this much. We will continue tomorrow. This is more interesting questions will come tomorrow.